Welcome to solverfy.
All right, so problem number 36 wants us to figure out if you're given the B meson quark combination as B minus is equal to B, a bottom quark, and an anti-up quark. So we need to verify that this is actually a physical combination. So to do that, we need to verify all of the conservation rules. So first, let's look at charge. So for charge, we have a -1 for the B meson is equal to, now quarks are kind of weird. They carry 1/3 charge, or 1/3 or 2/3 charges instead of 1/2 and 1 charges, basically, or instead of integer charges. So they carry a third or 2/3 charge. So for a bottom quark, it's a -1/3 plus an up quark, an anti-up quark. Well, an up quark carries a +2/3 charge, so an anti-up quark carries a -2/3 charge. So this is conserved. Okay, so now at the baryon number. So for the baryon number, we've got 0 for the B meson. Is equal to, now the baryon numbers for quarks are, again, they're weird. They're third. So 1/3 for the bottom quark plus the up quark would be 1/3, and the anti-up quark is -1/3. So -1/3, 1/3 plus 1/3 is equal to 0, so that's conserved. Now let's look at strangeness. So the strangeness of a B meson is 0, and the strangeness of the bottom and up quarks are both 0. So now let's look at the three characteristics of quarks: the charm, the topness, and the bottomness. So let's start with charm. The B meson is 0. And the bottom and the up quark are both have 0 charm. So that's conserved. Now let's look at top. The topness of the B meson is 0. And the bottom and up quarks both have 0 topness as well. So that's conserved. Now finally, that brings us to bottomness. Bottomness. Now, the B meson has a bottomness of -1, and the bottom quark has a bottomness also of -1, and the up quark has a bottomness of 0. So that's also conserved. So this is physical. So this is allowed. It's an allowed combination. Now, for part B, it wants us to work out the quark combinations for the different B mesons. So first, we're looking at the B plus meson. So the B plus meson is just the antiparticle of the B minus meson. So that means that the quark combination is just going to be the opposite of the B minus. So it's going to be the anti-B, anti-bottom quark, and an up quark. So that'll give, everything else is the same. It just flips. So because the charge is +1, these have to flip to conserve charge. The bottomness is +1, so the bottomness flips to conserve. That's so now for the neutral B meson, B0. So the charge, everything needs to be conserved. It must still have a bottom quark because it still has the bottomness. It needs to, and a charge needs to be conserved. So what we get is we get the B for the bottomness, and also things like the charm and topness need to be conserved as well. So, and the strangeness need to be conserved as well. So in order to do that, the only other quark that will conserve charge, the bottom quark has a plus 1/3 charge. So the quark combination has to have, I'm sorry, the bottom quark has a minus 1/3 charge, forgive me. So that means that the other quark that goes with it has to have a plus 1/3 charge in order to be neutral. So the only quark that can do that, that also doesn't carry any strangeness, charm, bottomness, or topness, is going to be the down antiquark. So that will conserve charge, that will conserve bottomness, that will conserve baryon, that will conserve everything else. So now finally, it wants us to do the neutral antiparticle. So the B0 antiparticle, the neutral B meson antiparticle. So it's going to be just like the same thing between the B minus and the B plus. It's just the antiparticle of the B neutral here, so it's just going to be the anti-bottom quark and the down quark, and that also remains neutral.